So now in this lecture, I'm just going to show you how to set up an artificial neural networks problem using Pytorch, and this is a very basic example. And before we move on to other things, I'm going to use this lecture as a way of introducing you to some of the concepts that we have spoken about previously and some of the concepts that we are going to cover further on in this course. So you can import pandas as PD, numpy as NP, iris pd.read_csv, iris.csv. These are the data. So we have the data for the sepal length, petal length, and we have 3 iris species. So the first thing we can do is to replace factors with numbers. So it doesn't matter the nature of your artificial neural networks problem. If you are working with artificial neural networks or ANNs, then the categories that you are trying to classify, they need to be in numbers. So, something like iris setosa won't work. You'll have to convert it to 1, 2, or 3. So iris.lock, iris species. So in iris species, I replaced iris setosa under the column species with 1. So this is what this chunk of code is doing. So iris setosa gets replaced by 1, versicolor by 2, and virginica by 3. And as you can see now in the species columns, I have numbers, and what we need are numbers throughout. And now before setting up the Pytorch problem, we have to change the pandas data frame to a numpy array. So I've created a variable data.train array iris.values, and we are going to split everything into the training and target, the x and the y variable. So this is, in the variable y train we store species, which are now in a numbers format, and the 4 columns which have the predictor data, which are my x train or the predictors. We are going to set up the ANN, and for that first we are going to import torch, import torch.nn as nn, autograd import variable. These are the hyperparameters. So we are going to have a learning rate of 0.01, number of epochs 500, and we are actually going to build a model. So we declare a class net. I call the function nn.module, which contains my neural network parameters. I initialize a definition, supernet self, and self fc1 nn.linear 4 hl, and we have 4 predictors, so I put in the value 4 here, nn.linear hl3, because we have 3 classes. And this is how we move forward. So f.relu self fc1 x. So basically x contains my predictors, and we are going to feed it through an activation function or the relu function. And what activation functions are, that's something I'm going to cover in the next lecture, but as you can imagine, that ties in with the architecture of the neural network. So basically x will be fed in, and then we get that. So now I create a variable net with a small n is equal to capital net, so this class. So basically this is a variable to store the artificial neural networks model, and I'm going to choose the optimizer and loss function criterion and then cross entropy loss, and this is my optimizer, the gradient descent, and this is the learning rate that we are going to use from here, 0.01. This is a very common learning rate. For epoch in range number of epochs, so this is a code we are going to run 500 times. I create a variable x, I call the function variable, and again I had already imported variable like so from torch autograd import variable, and as you know, this acts as a wrapper for the tensors, torch.tensor x train. So I'm going to convert my predictors to float tensors. That's why I say dot float. And then I create the y variable response variable torch.tensor ytrain.long. I'm going to keep them in the long format because essentially here we have integer value. So This is good for storing the integer response variable. That's why .long. Now I'm going to define a feed forward and back propagation algorithm, optimizer.0_grad. So we do that because we need to set the gradients to 0 before doing back propagation. Out net x. So I'm going to feed in my predictors, which are now stored as sensors, compute the loss by using the cross entropy function and comparing the predicted y value with the actual response variable. So remember, capital Y stores the actual response variable, and then loss backwards. So this loss is going to be propagated backward and so on, and we are going to do it 500 times. So in the first epoch, the loss is 1.974. Then it comes down to 0.79 and so on. So with this is basically how we set up a very basic artificial neural networks. And in the next lecture, we are going to look into the theory behind activation functions, because they are they essentially underpin artificial neural networks.